Hi, I'm Mitchell. This is a bit of research into future um, careers within software engineering or even slightly outside of it. So we'll go through. So I've broken it down into 3 sections. We've got in careers in software engineering, so we've got traditional. Most of the jobs you find for a software engineer, graduate software engineer, and I found junior software engineer, but there was others like Java software engineer or full stack software engineer. Generally, most of them will be a software engineer with a specific, either overarching like this one, and some titles will be specific on languages or the technology, like a full stack or a back end. But generally in software engineering, you'll get this prefix and then the software engineering. Related, so I put I found junior software developer and front-end software developer. There is obviously a lot more. I put developer as related because you don't need an engineering degree to do that role, but there is a lot of similarities between a software developer, even a computer scientist, I guess, and a software engineer. So very related in a lot of the things you do. The software engineer usually has a bit more training and has a bit more of an overview of the project or the program, whereas a software developer might be more working on specific tasks within the team. And then open, I put junior game developer, that's one I found, and a graduate analyst. So the junior game developer, again, they don't require a bachelor or degree, but they generally will take in a number of different types of game developers. So you have people who do blueprints, people who create plugins, or just creating plugins for projects within game engines. You have people who do C++ coding for game engines like Unreal. You have people that make game engines out of code, who have, like your Rockstar has its own game engine. So there's a lot of coding, a lot of engineering, a lot of development in it. So it's related, but it's not required, the degree. Graduate analyst, this one's a bit, so there is an analyst study, but an analyst will look at databases, SQL stuff, back-end stuff, which a software engineer will cover a fair bit of, looking through the Deacon syllabus. So I believe that a software engineer could probably, should be able to work into that role quite easily. From some of the jobs that I found, so in the technical skills, I found one that was strong knowledge of software engineering principles. So for this, in the skill development strategy, I put throughout the degree, review and understand the principles in software engineering and try to apply to projects, acquiring books such as Software Engineering Principles and Practice by Hans. So what I'm saying here is just keep in your mind the software principles like dry and solid and incremental changes and modularity, so that when you do projects, you kind of think about that and actually work it into it to make sure that you're using that. And in terms of, I guess, what role would require someone to have that skill, would be your engineers or your senior engineers who are in charge of a full project, or even a team of engineers, or might be head of a department of engineers who, like where I'm at Cubic, who would develop the engineering platforms and the kind of documentation on and the rules on how the engineers within our company develop software. So they would actually tell you, you need to do the C, using C language projects, you need to create a new folder for this, this part, because you want to make it as modular as possible. So that having that kind of engineering principle knowledge would help the senior people in making sure the people under them are doing it properly. Second, for the technical skill, I put strong knowledge in at least one of the following languages. So JavaScript, C#, or Python. I found that in one of the jobs. Again, so for this, I just would pick one language and develop a better understanding of its uses, syntax, and coding design through online courses, then using the language in a project or a series of projects. So that would be just pick a language. If you know that you're going to be coming out and doing one of these things, pick a language, find out what it can do. So some languages might be specific to certain things. A few years ago, JavaScript would have been only used for web development. Now it can be used for web development GUIs. It can be used for server side. It can be used for you can do services on Linux systems using it because of a Node.js. You can build desktop standalone applications using the Electron framework to do things like VS Code or Skype. I think Skype might be one of them. Anyway, so you pick your language, and then what would you do is throughout the course within the degree, when they say design a certain thing, but they give you a bit of leeway on the language you use, you might try, if it's able to, use that language to try and develop the system. That could be decided after doing your class diagrams and make sure you know that it can actually do those things first. So non-technical, I found that you are you are an articulate communicator and an inherent collaborator. So for this, I put communication collaboration is a huge part of software engineering and development. Due to software being worked on by a number of people at a time, it makes a huge difference when the team members communicate and work with each other to make sure tasks get completed on time and to possibly come up with better solutions. So I just kind of explained why it's important. So how you would learn that would be just working in groups throughout the degree, looking at open source projects online, doing a bit of code and committing it to some of those open source projects, branching off, maybe creating your own version of it. So it's, and making sure that when you have group sessions within Deacon within the subjects within your course, that you sit down, you whether it's remotely or when you're together, communicate with each other and work together to come up with a better solution. You might have come up with something, but maybe someone suggests something that can make it better. So having those kind of teamwork sessions, they're really good for that kind of building communication, the collaboration part. Last one I put is work from home during COVID and maintain teamwork. So to help with this, I put get used to video conferencing software and team code management software such as Git, Jira, etc. Git is already being used in multiple subjects such as SIT111, which I'm doing at the moment, embedded software. Getting used to branching the code for updates and pushing changes made back. So that's very specific. Just getting used to the full functionality of Git. Pretty much like the last one, it's work from home and teamwork. So again, it's about making sure that you can use video conferencing to communicate with your other team, which might be for meetings and updates on software, project times and such like that. So you would just do the video conferencing calls that we have at Deacon and a lot of the subjects, and get used to Git. Look into project management software where they can delegate certain parts of a project to people or to team members to make sure that you do this, you do that, and make sure that they are completing all the tasks and then signing off after you're done. So for me, my next step is to engage with colleagues at work and define the area in my engineering department that I will most likely go into. From the previous discussions, my main focuses will be on game development for simulation, networking and IoT for device control and effect systems, and embedded systems for soldier-worn devices. Although these would be the main area, I would not be limited to these and regularly work in geospatial software tools and full-stack web development. These tasks could be learnt through the embedded IoT and network subjects in Deakin, along with some of the online courses for full-stack development, which is an area I already work in. So I work for a company that does that contracts to defense doing simulated training. So a big one is game development for simulation, networking using it's called live virtual constructive, the mix of real world people running around and simulated people in a game, and how we can join those together and how we can use those. So a lot of AR, VR, XR style systems, and IoT devices for simulated training, where we do remote effect systems for triggering lights and sound and explosions and such. In terms of geospatial software tools, again, simulation is about replicating real life in the digital world. So it's we replicate an area of land in a 3D game. So I developed a tool that could a GUI interface for a user to select an area, and it exports files specific for Unreal to import with documents on how to set it up so that it creates a landscape within Unreal for the guys to then develop a system on top of. So they're the kind of tools we would look into a lot more. But yeah, that's kind of where I am and where I'm going. So yeah, thanks.